Okay, one very important thing to remember before we start any vector problem is we need to know what quadrant we're in. So once you determine your x and your y values, you're going to determine what quadrant those values fall in. So if the values are positive and positive, it's going to be quadrant 1, which is going to be on this side, if you didn't know. If it's negative positive, it's going to be quadrant 2, which is this side on the xy axis. Quadrant 3 is going to be right here, and that's going to be a negative value. And then quadrant 4 is on this, in this little area right here, and that's a plus minus value. It's very important to know these things when looking later on at our xy values, and then we're going to use these equations here to solve for what the question is asking, and we'll come back to this later when we continue the problem. Okay, so here we have a very basic problem for vectors. The question says, for the given vector, sketch a picture, then find the magnitude and direction. So our vector is 3, -8. And these numbers happen to be our x and our y values. So we're going to need that to start. To find the magnitude, the first thing you do is so this is the equation for finding magnitude. It's going to be the square root of your x squared plus your y squared values. So in our equation, it is going to be the square root of 3 squared plus -8 squared. And then this is going to equal the square root of 9 plus 64. And this equals 8.5. And that is our answer. Magnitude is just as simple as that. There's no harm, there's no foul in this equation. It's very simple. For direction, we are going to come back to our important sheet, and we're going to look at what quadrant our x and our y values are in. So we see we have a positive and a negative value, and we have a positive and a negative value in quadrant 4. So we're going to sketch a picture for this really quickly just to show where we are. So we're going to go over 3 for our x value. So this is negative, or say this is 3. And we're going to go down -8. See, that puts us in our quadrant 4. And then we can use our equation on this sheet here for quadrant 4. So it's going to be theta equals 360 minus the inverse tangent of y over x. So theta equals 360 minus tangent of -1 y over x. So in our equation, it's going to be theta equals 360 minus tangent -1, and then our y, which is our -8, or just 8 for this equation because we don't need to use the negative sign, and 3. And then that equals 290. So 290.55. And so we need to convert this into degrees. So we still have our 290 degrees, but to convert this, we need to multiply 0.55 times 60. And that's going to give us our 33. And that's it for direction and magnitude for just a very simple vector problem. Okay, so here we have a more difficult word problem for vectors. It says 3 forces act on point P. They are 25 newtons at 25 degrees, 65 newtons at 150, and 55 newtons at 225 degrees. Find the magnitude and direction of the resultant force on P. So the first thing we need to do in this equation is draw a picture. And sometimes this is the hardest part. So we're gonna put our point P here. We're gonna call that P. And then we're gonna have our forces acting on our point. So we have at 25 newtons at 25 degrees. So we're gonna have a force acting about right here. Say we're looking at a unit circle, that really helps. So this is 25 newtons. And then we're gonna go for 65 newtons at 150 degrees, which is this point. So we go 90 degrees, 150, which is about right here. Doesn't have to be exact at all. This is our 65. And then we have our 55 newtons at 225 degrees. So this is 180, 225 is going to be right here. And these forces are all acting inwardly on point P, even though I'm drawing the arrow, it's outwardly. They're going in to act on that point, and this is 55 newtons. Okay, so this is what our drawing looks like. So we know we have three different quadrants here as well, but that doesn't matter because we're going to be using the physics way for this equation to solve for our magnitude and direction. So the first thing we need to do is make an XY chart. And an XY chart looks just something like this, really simple. And then we're just gonna put our X values here and our Y. So we go, for our first one, we just take the newtons and the degrees that it's acting on. So we're gonna go 25 cosine 25 for this first one. And for the X values, they're all going to be cosine. That's an important thing to know for our X values. And our Y values are all going to be sine. Because on a unit circle, our X values are sine, or our X values are cosine, sorry, and our Y values are sine. So that's why we have that for our table as well. And so our next one is going to be 65 cosine 150. Because that's our value right here. And then 55 cosine 225. And then the same thing for this side, except you're using sine. Okay, so you're gonna solve for all of these equations, and then you're just gonna add them all together on both sides. But keep them separately. So these are added together and those are added together. And then we get our negative 72.52 and our 4.17. Okay, so we know that these points are in, so we can come back to our important sheet. We find that our X values are, we have a negative and a positive. So that's going to put us in quadrant 2. So we're going to be using this equation in quadrant 2 to solve for our direction. So the equation is theta equals 180 minus tangent negative 1, the inverse tangent, and y over x. So this is going to be theta equals 180 minus tan negative 1. Our y is 4.17 over negative 72.52. Alrighty, and then when we plug this into our nifty calculator, 180 minus tan negative 1, and then we just do 4.17 over, oh no, we don't have to put negative, 72.52. We get 176.7. And remember, we need to convert this to our feet. So we go 176 degrees, and then we multiply 0.7 times 60. And we get 42 feet. And so that's our direction for this problem. It's pretty simple for our physics way. you just make an X and Y table, and then you just use your newtons on this side and your degrees on that side, and you just solve for those, add them together, and figure out what quadrant you're in. That part's not that hard. And neither is the magnitude part. The magnitude part, in my opinion, is actually much easier. Let me just grab another piece of paper. So for the magnitude, all we have to do is we know that our magnitude equals the square root of our x squared plus our y squared. So we're just going to plug our numbers in there. So we have our negative 72.52 squared plus 4.17 squared. And you just solve for that, and it equals 72.69 newtons. It's that simple, everybody. So these problems, they look hard, but my advice is to figure out what pieces of information are the most important, and then sketch out a drawing of that so you can really visualize it, and then just figure out if you're going to use the physics way first, and then you just find out what quadrant you're in. It's really not that difficult, and magnitude is even more simple. So there you go. Those are both of those ways to do that.